All right, so let's talk about the in-class practice number 10 for the time series. So this is the second in-class practice. It is a little bit long. I just want to combine all the materials together so that you can get a better idea about the time series. Right, so the first question is a multiple choice question, right? So which of the following is relatively easier to estimate in time series modeling, right? So here we have the cyclical component, the seasonality, and the trend component, right? And D is no difference between the seasonality and the cyclical, right? So first, there will be a difference between the seasonal component and the cyclical component, right? So of course, number D is not right. All right, then you need to choose from A, B, C. Which one is relatively easier to estimate when you model the time series? Remember at the end of this chapter, I said what? I said the seasonal component is the most reliable component that can be estimated in the model, right? So since the seasonal component is the most reliable component, of course, it will be easier to estimate, right? Okay, so the answer will be the seasonality. All right, okay, so number 2, which of the following is an example of time series problem? All right, so first, it asks for which one or which is the example of time series problem. So what is a time series? We say any problem related with the time is considered as a time series problem, right? As long as the response variable is recorded by over the time, right? Then it will be a time series, right? So here, number 1, estimating the number of hotel rooms booking in the next 6 months. All right, number 2, estimating the total sales in the next 3 years of an insurance company. Right, number 3, estimating the number of calls for the next 1 week. So actually, all of these 3 options is about the time, right? So which one is an example of the time series problem? 1, 2, and 3, right? So it will be 3 of them. All right, so as I said in the chapter video, I said the time can be yearly, monthly, daily, every minute, every second, right? Every 2 minutes, every 3 years, every 5 seconds, something like that, right? As long as it is over time, then it is a time series. All right, so number 3, smoothing parameter alpha close to 1 gives more weight or influence to recent observations over forecasting. It is true or false. So let's determine by ourselves first, right? So the parameter alpha close to 1, what does that mean? We say alpha is the weight assigned to the current value, right? So alpha is the weight for the current value, and 1 minus alpha will be the weight for all historical values, right? So if alpha is close to 1, that means the current value is more important, right? So that means alpha close to 1 gives more weight or influence to the recent observations, right? So this one is true. All right, okay. And number 4, The following is a plot of monthly housing sales from 1973 to 1996. Right, so of course it looks, when you look at this plot, it's just a time series plot, right? So the x-axis is the year, y is the monthly, the monthly housing sales, right? So for each year, you will see the points, and then the points are connected by the lines, right? Okay, then number A, is the above plot a time series? What is the answer? Yes, right? Because what? Because it is plotted over time, right? So I just write in short. All right, so since it is a time series, then describe the time series with the components. Right, so if it is a time series, how many components we have? Possibly, we totally have 4 components, right? The first one is the trend component, right? Next one, seasonal component, right? Next one, cyclical component, and the last one, irregular component. All right, so we totally have 4 components. Now, based on this time series, describe the time series with these 4 components. Actually, it's just to ask you whether this time series contain these 4 components, right? So now first, does it has the trend component? What we look for a trend component? We look for whether there is an overall increasing trend or overall decreasing trend, right? So for this case, since the whole time series partially is going up, going down, going up, going down, going up, going down, but overall, is there an increasing trend or decreasing trend? Of course not, right? So we say, since there is no increasing or decreasing trend, so it doesn't have the trend component, right? Okay, so next one, the seasonal component. Does this has the seasonal component? That means we need to look for each year, right? Okay, so let's look at, okay, so this is 1975, this is 1980. That means there are 5 years between these 2 points, right? So actually you can see it is these 5, right? So that means for each year it will be going up a lot, going down, going up, going down, going up, going down, going up, going down, going down, going up. So that means the first season is actually increasing a lot and then decrease it, and then increase a little bit, decrease, right? So although they don't follow exactly the increasing or decreasing trend, but within each year, they follow the same pattern, right? So that means for seasonal component, yes, right? Because what? Because they, from 1975 to 1980, it contains similar pattern for each year, right? So we say it contains the seasonal component. Okay, so what about the third one? Cyclical component. We say cyclical component is the repeated pattern over 1 year, right? Okay, so let's look at, is there any repeated pattern over years? Over, or we say more than 1 year. Do you have it? Yes, right? So over 1 year, it's kind of going up, going down, going up, going down, going up. So that means this increasing, decreasing pattern will repeat about every, this is 5 years, this is about 2.5 years, right? Something like that. So yes, right? So this pattern repeats every about 7 to 8 years, right? So we say yes, it also has the cyclical component, right? Because it repeated every 7 to 8 years, right? Okay, so next one, the last one, irregular component. To find whether this time series has the irregular component, what we look for? We look for whether there is random fluctuation, right? The thing that you cannot see any pattern, right? So, but here you can see the pattern, right? And the time series is not something like that. You even cannot find any anything with pattern thing, right? So for this case, everyone follow the pattern, right? Quite smoothly, right? So it is no, right? There is no irregular component because there is no random fluctuation. All right, so let's continue to the next question. All right, next question, the demand in thousands of a particular item in the factory has varies as follows. So of course, this is the kind of the similar question as what we did in the last in-class assignment, right? So actually it is a time series. You have the year from 2013 to 2018 and you have the corresponding productions, right, in the demand, right, demand in thousands, right? So be careful about the unit when you interpret your results. All right, okay, so number A, based on the above time series, make a forecast of demand of this factory in 2019 using simple moving average with lag of 3. All right, so let's find the important thing in this question, right? So based on the above time series, make a forecast of demand in 2019. That means I need to find the predicted value, right? A forecasted value of y in 2019, right? So this is what we want. Using what method? Using simple moving average method. We say if we want to use the simple moving average method, we need to have the L, right? So here next information we have is with lag of 3, which is L equals to 3, right? So what does that mean? That means when this is the observed value of YT, right? If you want to get the predicted value of, let's say this, if you want to get the predicted value of 2019, what information you need? You need the estimated value of 2018, right? Okay, so to find this, how you can find that? We say it is lag of 3, right? So that means we are averaging the 3 observations, right? So that means if we draw it, right? So next line is about the estimated value at time t, right? Then you will need to average the first 3 to get the estimated value of we don't use t. Let's say the estimated value of 2015. There is no value available for these two, right? And then what? And then you need to average these three to get the estimated value of 2016, right? And then the average these three values to get the estimated value of 2017. And then the last one, you need to average these three to get the average of 2018, right? So if you want to get the estimated value of 2018, what you need to do is just the average of these three, right? So it's actually 128 plus 127 plus 131 divided by 3, which is 128.67. That's it, right? Remember the unit, which is, let's say, in thousands. So this is the predicted value or a forecast value of y for 2019. Right, so actually for simple moving average method, you do not need to calculate all of these estimated value first to make the prediction. You only need these three of them, right? Because L equals to 3. All right, so number B. Based on the above time series, make a forecast of demand of this factory in 2019. So actually the question is the same. I still asking about the predicted value of 2019. But now we are using exponential smoothing method with alpha given by 0.65. All right, so let's still think about this way, right? So if you want the predicted value of 2019, you need the estimated value of 2018, right? Okay, so how you can get the estimated value of 2018? Let me draw the table here so that it will not be messed up everywhere. Right, so we have 2013, 2014, 2015, 2016, 2018, 2019 outside, 120, 123, 124, 28, 127, 131. Alright, so this is about the year, which is the time t, right? So this is yt, the observed value of y at time t, right? So next, what we need to consider is their estimated value, right? Yt. All right, so actually to get the predicted value of 2019, you need the, not this, you need the estimated value of 2018, right? Okay, but remember what is the difference between the simple moving average method and exponential smoothing method? For simple moving average method, actually the prediction or estimation, it only depends on the previous three of them to get the average. That's all, right? So these three average doesn't depend on the previous estimated value. But for the exponential smoothing method, you need to calculate the estimated value from the beginning, because the next one is based on the previous one. Next one is based on the previous one, right? So actually what you need to do for the exponential smoothing method is you need to start from the beginning. All right, so let's work on that. We say YT estimated value by the formula A equals to alpha times YT plus 1 minus alpha times estimated value of T minus 1. Right, so what does that mean? It will be alpha times the current value plus 1 minus alpha times the previous estimated value. Right? So let's work on the first one, 2013. What is that? We say we need a starting point, right? So 2013, you don't have the previous value, so what you need to do? You just drop down here, just keep the same value for the first year, right? So the estimated value for 2013 is just 120. Alright, so from next year, we will need to use this formula. Alright, so then we have the estimated value of 2014 will equals to alpha, which is 0.65 times the current value. What is the current value? Is the YT at time 2014. Which is this 123, right? So for this estimation, the current value will be 2014, right? So it will be 123 plus 1 minus alpha, which is 0.65 times the previous estimated value, T minus 1, the previous estimated value. So what is the previous estimated value? It will be 2013. Right, so it will be 120. All right, so after you calculate this, you will get this is 121.95. All right, so continue. Next one, let's work on the estimated value of 2015. 2015 by the formula will be 0.65 times the current value, which is 124 plus 1 minus alpha, which is 0.35 times the previous estimated value, which is 121.95. Right? So if you get this, you have 123.28. All right, okay, then we just continue for the same procedure until the estimated value for 2018, right? So for estimated value of 2015 is 123.28, right? So how you calculate the estimated value for 2016? Alpha, right, which is 0.65 times 128 plus 0.35 times 123.28, right? So if you calculate this, it will be 126.348. All right, and then what about 2017? It will be 0.65 times 127 plus 0.35 times 126.348, right? So if you calculate this, it will be 126.772. All right, finally we can calculate the estimated value for 2018. How you calculate that? The same thing, right? So 0.65 times 131 plus 0.35 times 126.772. And then if you calculate this, you get it is 129.52. All right, so we come back to our question, right? So our question is to get the predicted value for 2019, and then after talk about that, we say it is just the estimated value of previous year, right? And then which is just here, right? So which is 129.52. This is in thousands, right? So the demand will be this much, right? So be careful, it is not just 129.52 because we have the unit. So it is 129.52 in thousands, or when you interpret the results, you need to say it is 129.520, right? So you can do change to thousands. That will be also fine. All right, so this is number B. I know it's a lot of calculations, but if you are patient and then just one step after one step, figure out what is the current value, what is the previous estimated value, and then your calculation will not be any problem, right? So next one, calculate the MAP. Right, calculate the MAP for both methods described A and B. And in your question, I just separate this question for A and B and decide which method provides a more reliable forecast. We say the smaller MAPE, the better, right? The more reliable for the forecasting. Right, so actually what we need to do is just calculate the MAP for the two methods, right? So now let's look at the first one. Right, so we need to calculate the MAPE by formula. What is the MAPE formula? It is 100 times 1 over n times the sum of yt minus yt hat divided by yt absolute value, right? So actually what we need to do is to find the pair of yt and yt hat, right? So here, be careful, it is yt with the predicted value. It is not for the estimated value, right? So we need to find this pair, right? So for A, we say this one, right? So we got the estimated value. Since we didn't solve for other estimated values for the A steps, right? So actually what you need to do is still need to calculate these estimated values. All right, okay, so let me just erase that and then calculate again. All right, so actually to find the predicted value, we need the estimated value, right? So actually for this kind of problem, you need to draw this table from your squash paper. All right, okay, so do you have the estimated value for the 2013? L equals to 3, right? So that means the first average will be based on these 3, and then you will have the estimated value for 2015. That means for the first two, you do not have any estimated value, right? Okay, so for the 2015, what is that? Will be 120 plus 123 plus 124 divided by 3. If you calculate this, you will have 122.33, right? Okay, and then for the next year, 2016, how you can get the estimated value? We move to the next three, right? So it will be these three, right? So it will be 123 plus 124 plus 128 divided by 3, which is 125, right? So next for 2017 will be the average of these three, right? So if you calculate this, it will be 126.33. And then the last, you need to get the average of these three, right? So which is 128.67, right? And then to get the predicted value for each year, you need to use the previous estimated value, right? So do you have the predicted value for 2013? You don't have the previous estimated value, right? So not applicable. Next one, 2014 predicted value will equals to estimated value of 2013, right? So since here doesn't have any value, this one, no. Right, next one, still no. Next one will be based on 2015, so you have the estimated value. So the predicted value for 2016 will be 122.33. Next one, 125. Next one, 126.33. Next one for 2019, as we did, will be this, right? Okay, now come back to our question, right? So we are almost forgot what we want to do, right? So we want to calculate the MAP, right? So we want to find the pairs of YT and YT hat, right? So do we have the pair for 2013? No, right? Because we don't have the predicted value per here, right? Do you have for the 2014? Again, no. Do you have the value for 2015? No, right? You don't have the predicted value. And then you have one pair for 2016, 128 for the YT, and then Y hat will be 122.33, right? So this is the first pair. Next one, 2017, you have another pair, right? For 2018, you have another pair. For 2019, do you have the pair? No, because you don't have the observed value for 2019. Right, so actually we totally have 1, 2, 3 pairs, right? So then we just say is equals to 100 times totally 3 pairs of YT and YT hat, right? And then for each pair we need to calculate the YT, which is the first one is 128 minus the YT hat, which is 122.33, divided by 128, right? So this is for the first pair. Next pair is absolute value of 127 minus 125 divided by 127. Then the last pair here is 131 minus 126.33 absolute value divided by 131. Right, so here we have the sum sum sign, right? So we need to add these three terms together, right? So if you calculate this, you will have it is 3.19. All right, so we got the MAPE for the first method. Let's calculate for the MAPE of the second method. The formula is the same. The way to calculate MAPE is also the same. But we focus on this table then, right? So for this table, we didn't draw the YT hat, right? So we just increase another one, another row for YT hat, right? So actually we are kind of switching their positions. So for 2013, do you have the predicted value for 2013? No, because you don't have the previous information, right? So you don't have that. You don't have the previous estimated value here. But from the 2014, you have the estimate, the predicted value, right? 120. Next one for 2015, 121.95. Next one for 2016, 123.28. Next one for 2017, 126.348. For 2018 is 129.772, and then for 2019 will be 129.52. Alright, so now we need to find is there any pairs of YT and YT hat, right? So we look for this row and this row, right? Do you have any pair for 2013? No, right? So do you have any pairs for 2014? Yes, 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 yes. Do you have any pair for 2019? No, because it doesn't have the observed value, right? So actually for MAPE of the exponential smoothing method, we have 1, 2, 3, 4, 5 pairs. So what we need to do, sum of 5 of them, right? So the first one is this one, right? So which is 123 minus 120, absolute value 123, right? Okay, so save the space, plus next term, next pair will be 124 minus 121.95 divided by 124. And then plus, all right, so about the third pair, I know it is a long calculation. 128 minus 123.28 divided by 128, right? So it will be this part. And then for the next pair, 127 minus 126.348 divided by 127. And the last one, which is 131 minus 126.772 divided by 131. All right, so after you calculate this, you will have 2.3. All right, so in the exam, I will not ask you to calculate so many terms, but here for the practice, I want you to practice again and again so that you don't have any problem with figure out which one is which, right? So in the practice, we practice more, but in the exam, we make it easier. All right, okay. So from the MAPE, we say the MAPE for the moving average method is 3.19, and the MAPE for the exponential method is 2.3. So which method provide a more reliable forecast? Exponential method, right? Okay. Number 6, based on the following time series, please suggest which method should we use to make better forecasting, smoothing method or regression-based method? Why? Right, so this question I'm asking about for different kind of time series, how you can decide to use the smoothing method or regression-based method, right? Because we have two classes of modeling methods, right? Smoothing method or regression-based method. Both of these two methods can make forecasting about the future, right? But there are advantages and disadvantages, right? So for this time series, which methods do you recommend? We say if the time series show the trend component, we can do the regression-based method, right? Because the smoothing methods is for the time series, don't have the trend component, don't have the seasonal component. But if a time series has the trend component, then we can always get the regression of it, just use the year as the time, the response variable as the y, and then we just fit the regression, right? So we say if the trend component is showed in the time series, then we will use the regression-based method. All right, okay. Next one, number 7. It says below we see a plot of closing price of DJIA with exponentially smoothed method using alpha is 0.70 and alpha equals to 0.15, right? So the question is, please identify which line is performed with the parameter alpha equals to 15, the yellow one or the purple one. Right, so here is actually we have two options, right, which is 0.70, another alpha is 0.15. We have the two lines. We say the yellow line is a smooth line, it's very smooth, right? And then the we say the purple line is actually not as smooth as the yellow one, right? So it can react to the rapid change very quickly, right? So actually here is asking you what's the difference between these two, right? 0.7. All right, so we say if alpha is we are looking for which one is for the alpha equals to 0.15, right? So let's just focus on this. If alpha is equals to 0.15, that means the alpha is close to 0, right? Okay, so remember what is alpha again? Alpha is the weight assigned to the current value, right? So if the alpha is closer to 0, that means what? That means the current value is not important, right? That means the previous estimated value, the previous values are important. Then it will not react to the current values change very quickly, right? Because it's based on the previous values. Then the line will be very smoothed, right? So for this case, which one is the smooth? will be the yellow one, right? So if alpha is 0.15, it should be the yellow line. The other way, if alpha is 0.70, it will be more like the purple line. All right. All right, so for number 8, number 8 is the regression output after the natural log transformation of the response variable cells. Right, in number 8, write down the regression equation based on the output. Right, so here we look for the equation. It will be y hat equals to whatever you got for b0 and b1, and then with the x, right? Okay, so this is the output. So actually, when we write the regression equation, we just say y hat equals to, this is b0, this is b1, right? So it will be negative 139.9242 plus 0.0713 times x, right? So here x is for the year, and this is regular, the simple linear regression, right? But is this the real regression equation? No, because the y here is not the real y. It is actually natural log of y, right? It's because our y here, the response variable, has been transformed from cells to natural log of cells, right? So this is the output after the natural log transformation. All right, so actually you can write this way, or you can also write as, I really care about the response variable, right? So then we can take the exponential to both sides. Right, so either way is okay, but you cannot just write y hat equals to that, because it is not just y hat. We have already did the natural log transformation. All right, okay, so number B. From the plot, we can clearly see the seasonal component, right? So this is the scatter plot. That means you will see that very high and then 3 low, very high, 3 low, very high, 3 low, right? So it is the seasonal component. How would you add this component into the regression? Describe it in details. We say to add the seasonal component into the regression, we need to create the dummy variables, right? So how many dummy variables we need? We need 3 of them, because seasonal we totally have 4 seasons, but for dummy variables we need to choose 3 of them, right? So here you need to describe it in details, how you set the dummy variables. You need to set the Q1 as the variable's name, right? So equals to 1 if the season is in Q1, 0 otherwise, right? The second variable equals to 1, 0 if season in Q2, 0 otherwise, right? The last one, Q3 equals to 1, 0. Let's say we use the Q4 as the default, right? Then it will be the season in Q3, and then 0 otherwise, right? So this is how you add the seasonal component into the regression, right? So first you need to set 3 dummy variables, and then for each dummy variable you need to set like this. All right, okay, so number C. After adding the seasonal component into the regression, write down the general format of the model. So you need to write the model of it, right? So what is the population model? Will be natural log of mu yt, right? Will equals to beta 0 plus beta 1 times x, which is for the year, right? And then we add the seasonal components into the regression, right? So that we have Q1, Q2, Q3 variables. We have 3 additional variables added into our regression. Then we'll have keep adding, right? So we'll have beta 2 with Q1, right? Next one will be beta 3 with Q2 with beta 4 Q3, right? So this is for the trend. These 3 is for the season, right? And then the question is asking, is it an additive model or a multiplicative model? Remember that now we have the trend plus the seasonal component, right? But it is about the natural log of y, right? But our final model is always about the y itself, right? Then you need to change to e to the beta 0 plus beta 1x plus beta 2 q1 plus beta 3 q2 plus beta 4 q3, and then you can change, this is for the t plus this is for the s, right? So you have the exponential to the t plus the plus times, right? So if the power is plus, that means it will be times e to the s. So this is multiplicative model. Alright, so here it's easy to remember that if your y is your original y, then you will have additive model. Otherwise, if you did the regression, if you did the natural log transformation, that means it is about the exponential, right? Then you will have the multiplicative model. So it is easy to remember. If y is the original y, then you have additive model. If your y is natural log of y, then you have multiplicative model. All right, so we're done with this assignment, right? Hopefully it gives you a better idea about the whole chapter. All right,